Hello, beta. Good evening, everyone. So, bache, in the last class, we had started with chapter 5.3 of Devore, and this is in your first unit of semester 2 stats part. And today I'm going to continue from there. So, we have already studied what is a statistic, and we also talked about what are IIDs, what is independent and identically distributed variable. IID किसको बोलते हैं उसके बारे में भी हमने एक बारी बात की थी. Now I want to go ahead and I want to continue from here. So today I want to talk about deriving the sampling distribution. How can sample distribution be derived? So in order to derive the sampling distribution, there are two techniques that we have. The first one is known as probability rule. And the second one is known as the process of stimulation. Right, beta? So there are two ways in which we can go ahead and we can derive the sampling distribution. The first one is known as probability rules. And the second one that we have, that is known as stimulation. Okay, let us talk about the example first. So ये बहुत interesting example है. Or actually on the basis of this example only, there is a back question given. तो जो क्वेश्चन नंबर 37 है आपका आफ्टर 5.3 पार्ट ऑफ डिवोर, दैट इज एक्चुअली बेस्ड ऑन दिस एग्जांपल ओनली. तो ध्यान से हम इस एग्जांपल को एक बारी देखते हैं बच्चे. इट सेज अ सर्टेन ब्रांड ऑफ MP3 प्लेयर in 3 configuration, a model with 2 GB of memory costing $80, 4 GB of memory priced at $100, and 8 GB version priced at $120. तो आपको 3 वर्जन दिए हुए हैं और उनके रिस्पेक्टिव प्राइसेस दिए हुए हैं कि आप या तो $80 अर्न कर सकते हो या 100 या फिर 120. 20% ऑफ द परचेजेस आर with 2 GB. तो आपको यहाँ पे percentage is given to you as 0.2. And then it says that 30% is with 4 GB. So you are given here 0.3. And then it goes ahead and says that 50% is with 8 GB. तो यहाँ पे आपको percentage दिया हुआ है बेटा 0.5. You are already given this information. ये आपको पहले ही दी हुई है. Right. अब ध्यान से देखो that this is the information given about the population. So in the last class, I had told you the difference between population versus sample. मैंने आपको इसका डिफरेंस बताया था और मैंने आपको ये बात क्लियर बोली थी कि देखो population is a bigger thing and पूरा का पूरा population may not be at your disposal. बट इसी population में से we pick up a smaller data set और उसको हम sample बोल देते हैं और sample के basis पे हम population के लिए कुछ infer करते हैं. So we try to understand more about the population based on the sample. ठीक है. Now try to understand that this data, the information that is given to you, जब भी आपको एक ऐसी general information दी होगी, whenever you will be given a general information कि you know इस इतने वाले को मैं इतने पे सेल कर रहा हूँ, इतने वाले को इतने पे, so that general information will always be the information belonging to the population. So in this case, beta, what we can go ahead and see, it says then the probability distribution of cost of single MP3 player is given by this. तो यहाँ पे बहुत ध्यान से हमें देखना पड़ेगा बेटा. इट सेज म्यू का मतलब हो गया पॉपुलेशन मीन. सो यू आर गिवन दैट द पॉपुलेशन मीन इज 106. और थोड़ा सा अगर हम आगे बढ़ते हैं, सो इट सेज सिग्मा स्क्वायर इज 244. इसका मतलब ये हो गया बेटा दैट पॉपुलेशन वेरिएंस that is given to you as 244. तो आपको population mean and variance दिया हुआ है. Before I go further into the question, एक बारी हम देख लेते हैं how these values are actually derived. इन values को कैसे derive किया गया है, we need to understand that also. So बेटा population mean को निकालने के लिए it is nothing but the expected value of this x. So how can I find the expected value of x? I will do 80 into 0.2 plus 100 into 0.3 plus 120 into 0.5. 120 into 0.5. So if I just try to solve this, I will get 80 into 2 by 10 plus 100 into 3 by 10 plus 120 into 5 by 10. So what will I get here? This will be 16. This will be 30. and this will be 12 into 5, that means 60. So you get 90 plus 12, that means 106. And you can see that here the population mean is given as 106. तो ये जो 106 हम यहाँ पे देख रहे हैं, this value that I see here, this 106, actually this is very simple. ये आपका सिर्फ expected value है, and the formula of expected value is nothing but summation x into px, and you can see that this is the expected value that you have in this case, right beta? Okay beta, now what I will go ahead and do now, we will focus on the second part. So look here that this says that the variance of the population is 244. Let us spend 1 minute and just quickly calculate the variance also. एक बारी variance भी निकाल लेते हैं. So in order to go ahead and in order to find the variance, so we know that the formula for variance is E of x square minus E of x whole square minus E of x whole square. So this is very, very simple. E of x square निकालने के लिए you need to do summation of x square into px. So E of x whole square, right beta? Acha, now if I just go to this part, if I just focus on this part, what will I realize? I will realize in this case that E of x square will be 80 square into 0.2 plus 100 square into 0.3 plus 120 square into 0.5. Right beta? So quickly we will go ahead and we will calculate this. हमेशा ना book में जो भी लिखा है, you need to understand what is written and why it is written. उस पे एक understanding होना बहुत जरूरी है. Just don't skip the book. Book ही सबसे important है, and you should understand each and everything written in the book. So if I just go ahead and I find out E of x square, what will I go ahead and get? So beta 80 into 80 into 0.2, this goes ahead and gives me 1280 plus 100 into 100, that is into 0.3, this gives me 3000 plus 120 into 120, that means 14400 into 0.5, that means it gives me 7200. Right beta? So if I just add this together, so plus 3000 and plus 1280, this gives me 11,480. So I am just 480. So I'm just going to go ahead and just going to put this value here. So this will be 11,480 minus E of x whole square, that means 106 whole square. So if I just do 106 into 106, I will go ahead and get 11480 minus 11236. So minus 11480, and this will give me the answer as 244. So therefore, I can go ahead and say that the variance will be 244. ये वाला part clear हुआ, how mean and variance are given to you. अब हम एक next step पे चलते हैं. So now what happens is, it says that on a particular day, 2 MP3 players are sold. तो एक दिन में हम 2 MP3 players sell कर रहे हैं. Now you need to understand बेटा कि वो 2 MP3 player कुछ भी हो सकते हैं. दोनों ही MP3 player 2 GB के हो सकते हैं. Both the MP3 player can be of 4 GB. Both the MP3 player can be of 8 GB. So I can sell them in any permutation combination possible. और ये with replacement case है. Because you can have the case where both the MP3 players sold are the same. दोनों ही आपके 2 GB वाले sell हो गए. So I have to create all those cases here. So I am selling 2 MP3 player. So this is the first MP3 player sold. This is the second MP3 player sold. So if both the MP3 players sold, they are this one. They are this one. 2 GB. ये 2 GB वाला MP3 player था. This was 4 GB MP3 player. And this was 8 GB MP3 player. So if both the MP3 players sold are 2 GB MP3 player, it means that my revenue will be 80. So this is what I have gone ahead and I have written here. Here I am writing the revenue as 80 and 80. Now if I go ahead and I tell you ki nahi, this is not the case. Rather I am telling you that, I am selling one 2 GB and one 4 GB. So it will be 80, 100. So I have gone ahead and written all possible cases here. यहाँ पे हमने वो possible cases सारे के सारे लिए हैं कि एक 2 GB, एक 6 GB, 8 GB, then 100, 80, 100, 100, 100, 120, 120, 80, 120, 100, 120, 120. So all possible cases जो भी हो सकते थे, that you can go ahead and sell one 2 GB and one 8 GB. तो 80, 120 का combination बन गया. We have written that. Or you can sell both 8 GB. तो 120, 120 का combination बन गया. So that is it. So I have gone ahead and I have written all possible combinations here. Now, beta, how is this probability calculated? So, in order to calculate this probability, this is simply the probability of x1, x2. ये joint probability है. But since these are independent events, choosing the first one is independent of choosing the second one. That is why in this case, this is simply equal to probability of x1 into probability of x2. हमने simply इन दोनों को multiply कर दिया. Why have I gone ahead and why have I multiplied simply? I have multiplied it directly because beta simply बात है that these are independent events. So you can go ahead and simply multiply them. ठीक है जी. तो this is what I have gone ahead and done in this case. तो अगर हम 80, 80 को देखते हैं बच्चे, so 80 का probability is 0.2. So 0.2 into 0.2, this will be 0.04. That is what is coming in the first case. So similarly, I have tried to fill this box. So अगर हम यहाँ देखें, this is going to be 0.04 and this is what is appearing here. This appears here. Similarly, the next one goes ahead and says 80 and 100. So, if I go ahead and take 80 ka probability is 0.2 and 100 ka probability is 0.3. So I will get 0.06. So if I go ahead and I see here, this is giving me 0.06. Now, in similar fashion, I have gone ahead and I have filled this entire column. ये पूरा का पूरा column is filled on that basis that you are picking up on the probability of the first one into the probability of the second one, and that is going ahead and giving you the joint probability, and I am able to multiply individual probabilities because these are independent events. So क्योंकि independent events है, I have been able to go ahead and multiply them together. Okay, beta. Now this says what is going to be, please understand, what is going to be the mean of your sample. What is going to be the mean of the sample? So the mean of the sample will be the first observation plus the second observation divided by 2. So if you can go ahead and see here, the first mean is coming as 80 because my first observation is 80 and second observation is also 80. So I can clearly go ahead and say that 80 plus 80 by 2 will give me 80. Now if I look into the second observation, which is 90, so it is nothing but 80 plus 100 divided by 2. So 80 plus 100 is 180. 180 divided by 2 is going to give me 90. And in similar fashion, I have gone ahead and filled this entire column. So देखो 80 plus 120 is 200 divided by 2 is 100. 100 plus 80 is 180 divided by 2 is 90. 100 plus 100 is 200 divided by 2 is 100. So in that way, I have been able to go ahead and find these mean values. So this column basically goes ahead and it represents the mean of the sample. Sample only had 2 data points और उनका मैंने mean निकाल के यहाँ पे लिख दिया है. Now let's talk about the variance of the sample. So what is the formula of the variance of the sample? Summation xi minus x bar whole square divided by n minus 1. Now in this case, beta, we know कि मेरा जो sample था ना, it only consisted of 2 observations. So this will be summation xi minus x bar whole square divided by 2 minus 1. So summation xi minus x bar whole square divided by 1. So this will be nothing but summation xi minus x bar whole square. So now if I go ahead and I look into the first row, पहली row को देखो, so this is going to be 80 minus 80 whole square plus 80 minus 80 whole square, that means 0. So you can clearly see that both the observations are simply the value of the mean. देखो यहाँ पर दोनों ही observations simply mean के बराबर ही आ रही हैं. So since both the observations are simply the value of the mean, the variance is going to be 0. तो यहाँ पे हमने variance को 0 कर दिया है. Now let us go ahead. So I'm going to just remove this from here. Now let us go ahead to the second one. This is done. Now let's look here. So their mean is 90, isn't it? So I will do for this one 80 minus 90 whole square plus 100 minus 90 whole square. So this is going to give me minus 10 whole square, which means 100, plus 10 whole square, which means 100. So this will be 200. So if you can go ahead and see in the second place, you can clearly see that this is coming as 200. Okay, beta, let's come to the third one. तो अब इस केस में हम देखेंगे, so what do we find out? We see 80 minus 100 whole square plus 120 minus 100 whole square. So 120 minus 100 whole square. So this will give me minus 20 square, that means 400, and 20 square, that means 400, so 800, that's this value. Again, beta, I am leaving it up to you. In similar fashion, you will be able to find all these variances. तो ये individual sample के variance हैं. So we have been able to go ahead and find the mean of the individual sample, and we have also been able to find the variance of the individual sample. So we have been able to fill these two columns. Up, most important thing, but we want to talk about these distributions. So up, because in the last class, I explained to you that sample mean is a random variable. So you need to understand that any random variable is associated with a probability distribution. And in order to understand the probability distribution of the random sample, हमें क्या करना होगा ना? We would need its frequency distribution. We would need its frequency distribution. So rather than directly focusing on this part, what I'm going to go ahead and I'm going to do is, I am going to find out कि कौन से जो x's हैं, x bar है, उनका क्या क्या value आ रहा है. What are the values that I can see here? Okay, so just I'm going to minimize this for a moment. So this is the table that we have created. And just focus on sample mean for now. अभी के लिए सिर्फ sample mean पे focus करो. Okay, so look that I want to focus on sample mean being 80. तो बच्चे, where all do you see the value 80? यहाँ पे दिख रहा है 80. Do you see anywhere else the value coming 80? No, we don't. तो इसका जो frequency of x bar रहेगा, that will be 1. Now let us focus on the mean value being 90. So where all do you see better the mean value being 90? So here we see that the mean value is 90. Here I see that the mean value is 90. So two places. So frequency will be 2. Now beta, I go ahead and I focus on the mean value being 100. So where all do you see the mean value being 100? Here I see that the mean value is 100. Here I see that the mean value is 100. Here I see that the mean value is 100. So its frequency is 3. Then I want to say that mean value is 110. So where all do you see that the mean value is 110? But here I see the mean value is 110. Here I see that the mean value is 110. So 2. And at last, we see that the mean value is 120 and its frequency is 1. Now, you need to multiply this frequency with the corresponding probabilities. So what has been the probability of 80 beta? The probability of 80 has been 0.04. What has been the probability of 90 beta? The probability of 90 has been 0.06. What has been the probability of 100 beta? It has been 0.10. What has been the probability of 110 beta? It has been 0.15. And what has been the probability of 120 beta? It has been 0.25. Am I clear with it? Okay, beta. Now what you will do now, you will go ahead and multiply the frequency with the probability. You will go ahead and multiply the frequency with the probability. So this will remain 0.04. This will become 0.12. This will become 0.30. This will become 0.30. And this will go ahead and become 0.25. Right? This is what you will be going ahead and getting. Now, what you get here, so you are going to go ahead and you're going to look into these. So 3, 4, 5, 6, 7, 8, and 9. And we had 10 observations, right? We had 9 only. Okay. So what you will be doing is now you will be just picking up on these X bars and you will be looking into these probabilities and you will be just going ahead and writing it here. Right? So you will be going ahead and you will be just writing them here. Am I clear with it? So look that for 100, so here is what the issue is, beta. Note that for 100, we have jotted a wrong probability by multiplying. The reason is that for 100, the probabilities are not the same that I can simply multiply. You notice that here for 100, the probability is 0.10, and here it is 0.90, and again here it is 0.10. It is not the case in any other case, but only for 100, it is like this. So, just directly multiplying with 3 will give me wrong answer because one of the probability differs to 0.9. So what I will do, beta, therefore, because this may seem confusing, so you may simply add the probability because I see a difference in the probability of 100 here, right? So for 80, it remains at 0.04. For 90, I see 0.06 here and 0.06 here. So it was same as multiplying it with 2, so 0.12. The issue is with 100. With 100, I see 0.10, but I see 0.09 here and then again 0.10. So this gives me the answer as 0.29. For 110, it's the same. I see the same number twice. So multiplying or adding gives me the same answer, 0.30, and here I get 0.25. So better add than multiply because we see a difference in the probability in this case. So you have been able to go ahead and you have been able to create this probability distribution table now. So this is what is reflected here. ये आपका probability distribution of X बन गया है. Similarly, I want you to make a probability distribution of the variance. Variance का भी probability distribution बन सकता है. So in that case, what will we do? Let's start with the probability distribution of variance, beta. So what are the values that variance takes? It takes the value 0. What is the probability associated with it? So for 0, corresponding 0 here, I see 0.04. For 0 here, I will see 0.09. And for 0 here, I will see 0.25. Right? Then you go ahead and you look at the next variance, and the next variance comes out as 200. So for 200, I go ahead and I see 0.06. And then I see 0.06. And I see 0.15. And I see 0.15. Right? And then I just go ahead and I write the third value, which is 800. So for 800, I see 0.10. And then I see 0.10. Right, beta? So if I just go ahead and I sum this up, so यहाँ पे I will go ahead and get 13 plus 25. So 0.38. This will give me 0.20. And this will give you 30 plus 12, 0.4. Always remember, whenever you will go ahead and add these together, this should give you the answer as 1. Always. And the sum of the probabilities should be 1. So what we note down here is that this is the probability distribution of the variance that we have got. Again, beta, I want to point this out that we are talking about the sample variance. And because sample itself is a random variable, so in the last class we had studied that whenever you're working with a random variable and you do something on the random variable, मतलब आप random variable का mean, median, mode कुछ भी निकालते हो, that also remains as a random variable. वो भी एक random variable ही रहता है. Right? So since the variance of the sample is also a random variable, क्योंकि ये भी एक random variable है, therefore there will be an associated probability distribution with it. उसके corresponding हम एक probability distribution बना पा रहे हैं. Now, What we can go ahead and do, therefore, beta, we can also just plot this, right? Because this is a probability distribution. I may very well want to go ahead and plot this. So for the mean, I can go ahead and say that, okay, for value 80, its probability is 0.04, and for 90, its value is 0.12, and for 100, its value is 0.29, and so on and so forth. So this is what the book has gone ahead and done. For different values, the book has gone ahead and made a histogram. This histogram in particular, it refers to the histogram of the population. So if you go back to the population may we had only three values. The revenue can be 80, the revenue can be 100, and the revenue can be 120. और उनका corresponding probability दिया हुआ था 0.2, 0.3 and 0.5. But sample के mean, if you notice, it varies more. तो जब हमने sample में देखा, तो we found that the mean can be 80. Welcome beta. The mean can be 80, the mean can be 90, it can be 100, 110 or 120. So what we note in the sample is that although the population could only take the values 80, 90 or 100, but we go ahead and we notice that in the sample, the mean can be anything from 80 to 120. This is an important point to make a note of it, right? Okay. Now, this is very, very important. Very important. Try to see this thing better. So, हमने क्या किया ना? हमने बोला we have a population at hand. The population had three things. Either my revenue could be 80 or 100 or 120, and we were given the corresponding probability 0.2, 0.3, 0.5. हमें population के बारे में पता था. And then we found out that the mean of the population is 106. Then we started making sample. So when we went ahead and we made the sample, जब हमने इसमें से sample बनाया, तो sample could have had any two observation. तो ऐसा हो सकता था कि इस सैंपल में दोनों ही जो हमारे वो आए, जो भी वॉट एवर मेमोरी कार्ड वी आर टॉकिंग अबाउट, उनका जो स्पेस है वो 80 GB वाला था. सो वी 2 GB वाला था. सो वी मेक अ रेवेन्यू ऑफ 80 ईच. एंड ये दो ऑब्जर्वेशन 80,100 भी हो सकते थे, ये दो ऑब्जर्वेशन 80,120 भी हो सकते थे. दे कुड हैव बीन एनीथिंग. सो ऑन दैट बेसिस ऑफ कोर्स वी वेंट अहेड एंड वी क्रिएटेड ऑल पॉसिबल सैंपल्स. हर सैंपल का हमने मीन निकाला. दीज वर द मीन ऑफ द सैंपल. नाउ लिसन टू मी वेरी वेरी केयरफुली. बहुत ध्यान से सुनो. इफ आई फाइंड द मीन ऑफ दीज मीन्स, जो भी हमने ये सैंपल के मीन निकाले हैं, वॉट एवर मीन वी हैव फाउंड आउट, अगर इनका ही हम दोबारा से मीन निकालें, इफ वी फाइंड आउट द मीन ऑफ दैट, मतलब क्या होगा बच्चे? मीन ऑफ मीन, व्हाट विल बी द एक्सपेक्टेड वैल्यू ऑफ मीन? इट विल बी 80. तो ये 80 वैल्यू आ रहा है मीन का, 90 आ रहा है, 100 आ रहा है, 80, 90, ये सब. सो इफ आई गो अहेड एंड आई फाइंड द मीन ऑफ दीज मीन्स, जो भी हमारे पास यहाँ पे वैल्यूज आई हैं, अगर मैं उनका मीन निकालूं, I will get it at exactly 106, which is the mean of the population. So this is a very important thing. Please make a note of it, that when we find the mean of the sample mean or expected value, when we find the mean or expected value of the sample mean, we get the value of population mean. हमें जो आंसर आता है, that is going to be the same as the population mean. हमें population mean ही मिल जाएगा. So try to understand बेटा. How do you find expected value? एक बारी मुझे बात बताओ, कैसे निकलती है expected value? It is summation. जिस भी चीज का expected value निकालना है, multiplied with its probability. तो हमें मीन की expected value निकालनी है, तो मीन की हमने probability distribution तो पहले ही बना लिया है. हमने सारे मीन लिख लिए and corresponding to that we have written their corresponding probabilities also. So we have already written these means and their probability distributions. तो अगर मुझे इन मीन का मीन निकालना है, if I need to find the expected value of these mean, तो क्या करेंगे बेटा? 80 into 0.04 plus 90 into 0.12 plus 100 into 0.29 plus 110 into 0.3 plus 120 into 0.25. And when you will solve this, आपको रियलाइज होगा कि यहां से जो आपको वैल्यू मिल रही है, द वैल्यू दैट यू आर गेटिंग इज एग्जैक्टली द मीन ऑफ द पॉपुलेशन. आपको इसको सॉल्व करके एग्जैक्टली 106 ही मिलेगा. एंड दिस इज अ बैक क्वेश्चन. जब आप एक्सरसाइज के क्वेश्चंस में जाओगे, अ वेरी सिमिलर क्वेश्चन इज इन द एक्सरसाइज, जिसमें आपको यही करना होगा. तो आपको क्या दिया होगा? यू विल बी गिवन अ पॉपुलेशन. उससे आपको एक्सरसाइज में बोला गया है कि यू हैव टू क्रिएट अ सैंपल. इन सैंपल के जो मीन है उनका आपको प्रोबेबिलिटी डिस्ट्रीब्यूशन बनाना है और उससे सैंपल का मीन निकालना है, मीन ऑफ मीन, एक्सपेक्टेड वैल्यू ऑफ मीन निकालना है. एंड यू नीड टू शो कि वो पॉपुलेशन के मीन के इक्वल है. And this is exactly what we have done right now. So same example is there in the final exercise. Please do that example as homework. सब लोग वो example करेंगे ही करेंगे. Okay बेटा. अब हम क्या करते हैं ना, let us try to find out the expected value of the variance. तो हमने ये sample variance का probability distribution यहाँ पे बनाया है, right? हमने यहाँ पे इसका probability distribution create किया है. So if I ask you, beta, what will be the expected value of this? तो आप बोलोगे, and this is nothing but value multiplied with its probability. So 0 into 0.38 plus 200 into 0.42 plus 800 into 0.20. And when you will go ahead and you will solve this, so 200 into 0.42, this will give you the answer as 84. Plus this is 160, this will give you the answer as 244. और ये क्या था 244? This 244 was nothing but it was actually the variance of the population. It was nothing but the variance of the population. So अब हमने यहाँ से ये भी prove कर दिया है that the expected value of the variance of the sample will be equal to the variance of the population. The expected value of the variance of the sample is equal to the variance of the population. Again, beta, ये question back exercise में it is given to you and all of you will go ahead and try that question. ठीक है? Okay. So we have done this. ठीक है बेटा. So now you can go ahead and you can look into example 5.21. बहुत simple example है. In this example वो क्या बोल रहे हैं ना कि let x1 represent the service time that it takes to serve customer 1 और x2 has service time to serve customer 2 and both of them they are exponentially distributed with the factor lambda. Both of them are exponentially distributed with the factor lambda. And therefore, जो total time होगा, that will be x1 plus x2 that we will be having in this case. अब ये बोल रहे हैं what is the probability that both the customers will be served in some time. जैसे अगर मैं आपको बोल दूं कि किसी भी एक कस्टमर को सर्व करने के लिए मुझे x1 मिनट्स लगते हैं और किसी भी दूसरे कस्टमर को सर्व करने के लिए मुझे x2 मिनट्स लगते हैं, then what is the probability कि जो टोटल टाइम मुझे लग रहा है वो लेस देन इक्वल टू 10 मिनट्स है. Right? So whenever you go ahead and you want to do something like this, so in a way, I need to find the CDF. CDF to less than equal to पे काम करता है. From the last semester, we know this. So beta, we need to go ahead and we need to find the probability that probability x1 plus x2 is less than equal to t. तो हमें ये निकालना है what is the probability x1 plus x2 is less than equal to t. ये चीज हम लोगों को यहाँ पर फाइंड करनी है. Now this is going to be the joint distribution क्योंकि x1 plus x2 है, so I need to go ahead and I need to work with the joint distribution. So this is what I am going ahead and doing here. This is going to be the joint distribution और इसको हम integrate कर रहे हैं. So if I just go ahead and I want to plot this thing somehow, तो इसको कैसे plot कर सकते हैं? तो I am going to take it with an equal to sign first. So x1 plus x2 is equal to t. So I am taking x1 here. I am taking x2 here. And क्योंकि x1 plus x2 equal to t है, so this will be a line like this. यहाँ पे भी t आएगा और यहाँ पे भी. Isn't it? You can always see this, na? So when you will go ahead and you will put x1 as 0, तो x2 का value t आएगा. And when you will put x2 as 0, तो x1 का value t आएगा. So you will notice that you will go ahead and get something like this. Now when I go ahead and I tell you कि x1 plus x2 is less than t, so you will shade inside, right? अच्छा, now if I go ahead and I take any point beta on the line, suppose मैंने बोला यहाँ पे ये x1 है, तो यहाँ पर ये point x2 होगा. And because this is on the line, तो हमें पता है कि x1 plus x2 should be equal to t. We know this thing. So from here, can't I say that x2 will be t minus x1? So the coordinates of any point here, it can be rewritten as x1 comma t minus x1. I can go ahead and write the coordinates in this format, x1 comma t minus x1. This is what I have gone ahead and written here. So my x2 goes from 0 to x2, but x2 is t minus x1. And then x1 goes from 0 to t. x1 goes from 0 to t. And this is the joint distribution function. ये हमें joint distribution function दिया हुआ है. तो actually this is from last semester. ये हमारे लिए इतना relevant इस sem के लिए नहीं है. We have already done this thing. So what you can go ahead and do is you can first integrate with respect to x2, and whatever answer you will be getting, then you can integrate it with respect to x1. If there is still any doubt, I will take this in the doubt class. But as of now, this is how you can go ahead and you can solve this. Huh? So this will be your answer. अच्छा, ये आपका CDF function निकल के आएगा यहाँ से. When you will integrate it, पहले आपने इसको with respect to x2 integrate किया, then with respect to x1, you will get your CDF function. So if I want to go to the PDF, then I know that I can just differentiate the CDF function and I will be able to get the PDF, right? So यहाँ से we can at any point of time get the PDF also. Okay, beta. Now let's go ahead to the next mechanism. So this is known as the simulation experiment. So simulation experiment will be rarely asked in exam. बहुत rare इससे question आता है कोई exam में, तो ऊपर से समझ लेते हैं what this says. It goes ahead and it says that in this case, what we are going ahead and doing is we are going to use a computer software. तो मैं सिर्फ अपने computer के पास गई and I tell the computer कि देखो ये सारा मेरे पास population है and I want you to generate a sample. So I am not going to go ahead and do it myself. Rather, what I'm going to go ahead and I'm going to do is I am going to do it based on a computer software. Right, beta? तो यहाँ पर हमने usage of computer software करना है. And in order to do simulation, we need the following things. हमें इन सारी चीजों की जरूरत पड़ेगी. So the first thing that we need is called as statistic of interest. मतलब what am I interested in? Am I interested in finding the means? Am I interested in finding the medians? Am I interested in finding the mode? What am I interested in finding? That's the first thing I want to know. The second thing is what kind of population distribution am I talking about? Is it normally distributed, exponentially distributed? What kind of distribution is it जिसमें से मुझे sample निकालना है? Like for example, when you refer back to the start of the book, तो हमने start किया था कल का lecture saying that it's a Weibull distribution, right? So we must know what kind of distribution we are talking about from which we need to find out the sample. That's the second thing. The third thing is we need to know the sample size. कि कितना sample निकालना है? Do I need, जैसे for example, again if I go back to the example of the last class, we had a sample size of 10. हमने एक sample में 10 units रखे थे. And we need to know how many replications we require. So for example, in the last lecture, we know that we had collected 6 samples. तो एक ही population से कितने samples निकालने हैं और हर sample में कितना observation होना है, we need to go ahead and we need to know all of that. So this is our diagram which is given in the book. And if you see this diagram, it's very interesting to understand कि जैसे जैसे आप अपना sample size बढ़ाते जाते हो, as you increase the sample size, you will notice that you will be having better answers. You will be approaching the value of the population. And as you increase the number of the samples, जैसे बेटा यहाँ पर if you just go ahead and look here, I am just going to go to the example yesterday. तो यहाँ पर हमने कितने samples दिए थे बच्चे? We had gone ahead and we had taken 6 samples. So our expectation is कि जब हम इन 6 samples का mean निकालें, mean का mean, when I find out expected value of the mean, it will be close to the population mean. But the claim is कि as you increase the number of samples, जितने आप samples निकाल रहे हो population से, as you increase those, you will notice that it actually goes ahead and it becomes better estimate of the population. It becomes better estimate of the population. Am I clear with that part? Okay. So this is what is important from the simulation part. Not a lot of things important from there. बस इतना आपको याद रखना है that for simulation, we need this information. Where is it? Okay. So all you need to remember is that for simulation, we need this information, which means we need to know what is the statistic of interest, what is the population distribution, sample size and number of samples. उसके basis पे हम अलग-अलग number of samples and sample size generate कर सकते हैं. और जैसे जैसे हम number of samples जो generate कर रहे हैं वो बढ़ाएंगे, then it will become a better approximation. हमारा जो model बनता जाएगा वो एक better model बनता जाएगा. Okay. Now this is a homework question that I am giving all of you. Question number 37 of section 5.3 is a homework question. And to get the solution of this question and to get all of these notes beta, you can go ahead and you can download our app ArthaPoint from the Play Store. Right? Or in that app, you will be able to see the solution to this homework question. And you will also get access to all these notes of Devore. Devore chapter 5. Okay, beta. So please, you can go ahead, download this app. You will be added to the, just go ahead and drop a WhatsApp also. So you can drop a WhatsApp on 83686 that we will add you to the statistics batch. Okay, beta. Fine, bache. So now I will meet you in the next class. Thank you.